So in this class, let us design a butt joint to connect two plates of 10 mm and 18 mm thickness to carry a factored load of 750 kN using M20 bolts of grade 4.6 and the thickness of cover plates given is 8 mm. So see here, the diagram runs like this. Here we have two plates to be connected. So this is the first plate. The thickness of this plate is 18 mm. 10 and 18 I have taken. So 18 mm is the thickness of this. This should be connected to a 10 mm thick plate. So this is 10 mm. So please note that the thickness of the two plates are different here. So these two have to be connected with a butt joint. So in order to have the connection, we have to provide one additional plate here to cope up this difference. The difference is 8 mm. So this plate is called as the packing plate. So packing plate has to be provided whose thickness is 8 mm. Now once after providing the packing plate, now we have to provide the cover plates. He has given that the cover plate thickness as 8 mm. So there are two cover plates. Let us provide a double cover butt joint like this. So this thickness of this cover plate, he has given it as 8 mm on either side. Now we have to design this using bolts of M20 grade. Connection we have to design. Now since I have not given anything about the grade of steel, we can assume Fe410 steel for the plates. So that is Fu is 410 Newton per mm square. And since it is grade 4.6 bolt, M20 bolts of grade 4.6, so the value of FUB is 400 Newton per mm square. Now the factor load to be carried is 750 kN. So you need not multiply by 1.5 because already it is factored load. Now the thing is, here this is the additional thing, the packing plate is additional thing. In the code, he has given one specification in page number 75. So here the thickness of packing plate is 8 mm. It is 8 mm here. You refer to page 75 of the code. So in the class 10.3.3.3, he has given one thing, packing plates. The design shear capacity of bolts carrying shear through a packing plate in excess of 6 mm. So here the packing plate thickness is 8 mm, which is greater than 6 mm. Suppose if the packing plate thickness is greater than 6 mm, then we have to calculate one factor called beta pk. Beta pk we have to calculate. So which is given by 1 minus 0.0125 TPK, where TPK is the thickness of the packing plate. So it is 1 minus 0.0125 in millimeters, of course, into 8. So if you simplify this, you are going to get the value as 0.9. So 0.9. So beta pk is 0.9. The meaning of this is the shear capacity of the bolt is multiplied by this 0.9, or it is the shear capacity reduces by 10%. So that is the meaning. So when we are calculating the strength of the bolt in shear, so we have to multiply the whatever value you are going to get by this 0.9. Now let us calculate the strength of bolt. M20 bolt, of course. In double shear, here it is double shear because it is double cover butt joint. So there will be two shear planes. This is one shear plane, this is another shear plane. Where the bolts are connected, there will be two shear planes. So this is one shear plane, second shear plane. So that is why we had to calculate the strength of bolt in double shear. So as you know, the formula VS PB, VDS, yeah. So in page number 75, the formula is given VDSB is equal to VNSB divided by gamma MB. We have already used this formula. So VNSB of course is given by FU by root 3 into of course gamma MB I will write here. This into, so since it is double shear, so 2 times I can take AN into, of course 2 times AN, that is enough, into NN will be 1. So you can take AN means ANB. So this is the formula we have to use. Earlier also we have calculated. So here the thing here is FU for the bolt we have to take. It is 400 divided by root 3 into 1.25 is gamma MD into 2 into, this is 0.78 times pi d square by 4, 20 mm diameter. So this is the value we are going to get. This value will be in newtons. So you can just calculate this. Of course, this should be multiplied by 0.9. So this 0.9 we have to multiply because the strength of the voltage here will reduce because of the packing plate. If it is packing plate is up to 6 mm, there is no need to provide there is no need to use this reduction factor. If the packing plate is greater than 6 mm, here it is 8 mm, we need to multiply this whatever value you are going to get by 0.9. So this will be in newtons. Let us calculate this. So it is pi into, of course this is 400 by 4 is 100 into 0.9 into 0.78 into 2 into 400 is equal to divided by 1.25 is equal to divided by root 3. So you are getting 81.49 kilonewton. So this is the strength of bolting double shear. Now, since we don't know the value of end distance or pitch, let us take this itself as the strength of bolt and let us calculate the number of bolts required. So we cannot calculate now the strength of bolting bearing because for the calculate strength of bolting bearing we need a P value, E value and all to get the value of KB and then to get the value of strength of bolting bearing. Number of bolts, as you know, it is equal to P divided by this strength of bolting double shear. P you have 750 kilonewton divided by 81.49. The number of bolts, total number of bolts required is 750 divided by 81.49. So 9.2 bolts we require, say 10. So let us provide 10 bolts now. But these bolts are provided in 2 rows. So let us provide the bolts in 2 rows. So this is the first plate and this is the second plate. So let us provide the bolt in 2 rows. So it will be like this. I will provide 2 bolts here 1, 2, 3 bolts here. So number of holes is only 2. So now you can see here, let I will show the diagram here. Let me provide 2 bolts here. This is how it is provided, like this. And I will provide 2 more bolts here. Like this. And one will be provided here for the packing plate. Packing plate also will be connected, at the end, like this. So this is how the arrangement is done. So it is like this. In plan, it looks like this. So of course, we have not given anything about the width of the plate and all. Let us not worry about that. So here, this is how we have to compute. Now, to compute the pitch. Now we have to compute the pitch, and then after computing the pitch, we need to calculate the strength of bolt in bearing, and we have to prove that the strength of bolt in bearing will be greater than this. Then this will be the criteria. So our assumption will be correct. Now let us calculate the pitch now. For calculating the pitch, so we need to equate this value into here there are 2 bolts, so there will be 2 bolts. This is strength of 1 bolt. So you will be having 2 bolts in each row. Therefore, per pitch length we have to compute. So we have to compute the strength of 2 bolts will be equal to, that should be equated to the net tensile strength of the plate per pitch length. Net tensile strength of plate per pitch length. Now, let us see how we can equate this. So, strength of 2 bolts, because there will be 2 bolts per pitch length. So, strength of 1 bolt is 81.49. So, strength of 2 bolts should be 2 times 81.49. This should be equal to net tensile strength of plate per pitch length. Once again, it is given in the code. So, 0.9 Fu by gamma m1. Fu by gamma m1. This formula I have used earlier also in the earlier problems. Into P minus dH into T. P is the pitch. P minus dO or dH into T. So this is the equation we have to use for the net tensile strength of plate per pitch length. Now here, so the thing is, if you simplify this, here P is the unknown, 0.9 into, so strength of plate here is 410 divided by gamma m1 is 1.25 into P minus D naught here is 22 mm, because you have that 20 mm as the diameter of the bolt, so plus 2 mm we have to add. So into thickness of the plate, so thickness of the plate T, you have to take 10 mm. So minimum thickness of the plate you have to take. So this is how. So out of 10 and 18, you have to take the minimum thickness of the plate. So if you simplify this, you will get P is equal to, a pitch value is equal to 77.2 mm. 77.2 mm. Can just simplify that. Say 80 mm. So we can provide 80 mm pitch value you can provide 80 mm, and the end distance E is equal to 1.5 times d naught, 1.5 times 22, 33 mm, say 35. Say 35 mm. Okay. So end distance I am going to provide 35. So here, see here, please note that this is the pitch. So if you take per pitch length, you have from center to center here. So in this thing you have two bolts, half here, half here, half here, half here, center to center. So that's why two I have taken here, and that should be equated to the rectangular of the plate is given by this formula P minus D naught. So why we have using D naught here is this is P, and in that we have deduct one bolt only, half here, half here. That's why it is P minus D naught. Now, if you simplify this, you are going to get P this much. Now we have rounded up to 80 mm, and end distance 1.5 times D naught as per the code. So it comes 33. We will provide 35. Now what you have to do is, earlier we have taken the strength of bolt as the criteria, and we have calculated number of bolts. So this itself we have taken as the strength of bolt, and we have calculated the number of bolts. Now we will check the other criteria, which is strength of bolting bearing. The strength of bolting bearing should come more than this, because among the two, the least value we are taking. Now we have assumed that the strength of bolting shear is the criteria for the design, and now we have to verify whether that is correct or not. So for that, what we have to do is we have to calculate strength of bolt in bearing. So once again, in page 75 of the code, the equation is given. Already we have used this many times. The equation, page 75. So strength of bolting bearing is VDPB. VDPB is equal to VNPB divided by gamma V, where VNPB is equal to 2.5 times KB into D into P into Q. Here, please note that KB is the least of. There are four criteria. First one is E divided by 3D naught. Second one is P divided by 3D naught minus 0.25. Third one is FUB by FU, and fourth one is 1. Now let us calculate. E is 35 mm end distance. So this is the end distance, and we have to take here. This is the end distance, and of course here this becomes the end distance. This is the pitch, and this is the pitch. Here, this is pitch, and then end distance will be this one. So 35 divided by 3 into 22. This is 80 divided by 3 into 22 minus 0.25. This is 400 by 410, and this is 1. Now let us get the values of these things. And about before we have to take the list. 35 divided by 66. It comes to 0.53. Second value, 80 divided by 66 minus 0.25, which is 0.96. Third one, 400 divided by 410, which is 0.975. Lastly, so among these four, the least value is 0.53. So this is the value of KB. So KB is 0.53 here, D is 20 mm, T is the thickness of the finger plate 10 mm. So among 18 and 10, the finger plate is 10 mm, and Fu is for the plate 410 newtons per mm square. Now substituting these things here, we get VLPB as 2.5 into 0.53 into D is 20 mm into T is 10 mm into 410. This value will be newtons. Afterwards we can convert it into kilonewtons. 2.5 into 0.53 into 20 into 10 into 410. So we are getting 108.65 kilonewton divided by 1000 I have done. Then one supplement VNPB, you can get the value of VDPB. VDPB is VNPB divided by gamma MB, which is 1.25. So this divided by 1.25, 86.92. So kilonewton. So please note that this value is greater than the strength of bolt so that is 81.49 kilonewton strength of bolt in shear. This is the value. So our assumption that strength of bolt in shear is the criteria is okay, because among these two we have to take the lesser value and we have to design. Already we have taken this value and we have designed to find the number of bolts. So this is okay. So now the final connection will have 10 bolts arranged like this, with a packing plate and two cover plates of 8 mm, packing plate of also 8 mm, with a pitch of 80 mm center to center of the bolt and end distance of 35 mm. So this is the double cover butt joint which is provided to transfer a factored load of 750 kN among these two plates. So in this problem, packing plate has been provided. So that criteria we have used as per the code. If the packing plate thickness exceeds 6 mm, so the strength of shear, the strength of bolt in shear will reduce by a factor beta pk. So that means the strength of bolt in shear, whatever you are going to calculate, that should be multiplied by that beta pk. In this problem we got it as 0.9. So the value is reduced because of this packing plate and the remaining is there. So we have to get the picture. So this step is important because if you equate the connection strength to member strength. So this is the connection strength LHS. This is member strength. If you are equating these two, so your efficiency will be highest, because efficiency is calculated as strength of joint divided by strength of the member. So when you equate these two, you will get 100% efficiency. So it may not be 100%, so it will be nearly equal to 100%. So that is why this is the criteria to calculate the value of pitch.